Hey everyone, this is Paul with another demo video for all of our Insider friends out there. As you're watching this, we're actually in Europe right now, in between a couple of conferences, but I recorded this about a week ago at the start of June, so I could avoid having to try and upload demo videos from Europe all the way over to our servers in Redmond. Anyway, in this video what I'm going to do is I want to show you some Tempdb latch contention weights occurring, and we all know about these. You have to have multiple data files in your Tempdb to avoid these things happening sometimes. But I want to show you one kind of latch contention that you can't do anything about because it's a system table and there's just no way to spread the load. So what I'm going to do is I'm going to create a scenario where I have a table in a database, a very small table in a database, and my test scenario is going to be lots of connections, all creating a small temp table and then copying all the data out from this sample table and then dropping the temp table again. So a classic Tempdb contention scenario where you've got lots and lots of threads creating and dropping temp tables. Now, even though my dev team, and I've blogged about this a lot, even though my dev team in 2005 changed the Tempdb allocation system so that there's a temp table cache, once you've got lots and lots of threads all creating and dropping temp tables, you can overload that cache. It's not a very big cache, it's either 32 or 64 temp tables. So if I spin up a couple of hundred clients, I'm going to see contention. So I'm going to go ahead and do that. I have this code here, and you're going to get a copy of all this code. So I have code, it's in the Tempdb client, and that just runs an insert select into a global temp table in Tempdb. What I'm going to do is I'm going to spin up a couple of hundred clients on my nice fast laptop. So I got 200 clients now. Let's go back over to Management Studio and have a look and see what's going in terms of weight stats. So first of all, I'm going to clear out the weight stats, and then let's see what we've got going on. So we've got a lot of latch weights. Now, the various kinds of latch weights, there's latches on internal structures that SQL Server is using, there's latches on copies of pages that are in the buffer pool, and there's latches that are waiting for pages to be read in from disk. So a page I/O latch is one that's waiting to be for a page to be read in from disk. A page latch without the I/O is contention for the latch on a page that's already in memory. So even though we might be holding locks, they're completely irrelevant in terms of actually making changes to the in-memory structures. The storage engine has to hold a lighter weight synchronization mechanism called a latch to be able to do that. So what we're seeing here is that the prevalent weight types on my server are contention for in-memory copies of pages. So we can have a look and see what pages there are actually that are being contended for. So a share weight is waiting for read access, an EX weight is waiting for exclusive access, a UP weight is waiting to eventually get exclusive access. So looking at DMOS waiting tasks, what we can do, and this is some code put together by Joe Sack that I've based this on, what this code will do is show me everything that's waiting on the system and what it's waiting for. So what we can see is we have a whole bunch of weights, and we can see a whole bunch of different page types, but one of the ones that's most prevalent is this one, 2:1:1. So that is Tempdb, database ID 2, file number 1, page number 1. So that's the first PFS page, page free space page, which deals with page allocations and deallocations. This is one of the classic pages that you see page latch contention on in Tempdb with this kind of workload. So we can get rid of, well, or at least we can reduce the contention that occurs on this page by going and creating another Tempdb data file. So if we go and create another Tempdb data file, what we should see is that the contention is now spread between the two data files because of what's called round-robin allocation. So if we go back and have a look at DMOS waiting tasks, we can see that there's now very little contention for page 2:1:1. But what we are seeing is we're seeing contention for some other pages. Right? Now, here's one that is very prevalent, 2:1:103. Okay. So 2:1:103 is a system table page. And we could go and trace back through DBTC page and figure out exactly what that page is, but I can tell you what it is. It's a page it's the first page, and it's usually the only page in a system table called sys multi-obj refs. And that deals with anything to do with queries that are referencing multiple tables. And one of the things, objects that are referencing multiple tables. And you can see extra rows being put into this table if you're using things like views. It also gets parted on if you're doing things like select intos. And because my workload is doing select into, that's why we're acquiring latches on this particular page. Now, unfortunately, there is absolutely nothing you can do about this. There's no way to spread the contention over multiple files because this table doesn't have multiple pages usually. So unfortunately, even though you can get rid of some of the contention that exists in Tempdb, for certain workloads, for certain kinds of operations that you're doing, there is some Tempdb contention that you cannot do anything about. Now, the SQL team knows about this, it's a known issue. Hopefully something will be done about it in one of the future releases. But right now, as far as I know, there's absolutely nothing you can do. So this is a bit of a shorter demo than we usually do, but I just wanted to show you this problem because it's now starting to crop up on more and more people's systems where they're seeing this kind of contention and kind of fighting against it and not being able to do anything. So just a quick educational video about what this is and what it means. So thanks very much for watching, and thanks for being a SQL Skills Insider.